Alright, this is our lesson on 2-2. Starts with radians and reference angles. So we haven't quite got to, or we're not ready for unit circle stuff yet. We just want to refer to radians and their reference angles. So the first thing we start with is some definitions. A definition of a radian, there's a few ways to put it. You can read that yourself and pause this. But the other way that I describe them is a radian is just the measure of the angle whose arc length is equal to the radius of the given circle. So if I have a circle, let me draw a circle here. If I have a circle, why is it not letting me draw? There. Okay, so here's my circle. If I drew an angle like this, then the length of this chunk of the circle will be equal to this radius. And that, when that is true, that is 1 radian. Other stuff we need to talk about, standard position, that would be starting on the positive x-axis. So that would be like right here. Standard position, your initial side starts at the origin, points to the right, and then you would go counterclockwise around in a circle until you get to the terminal side. The terminal side would then be the other side of your angle. So I think those are all things we've heard before, we're pretty familiar with. We just may not have used those terms since last year when we did the math of it. So moving on, we are first going to start with sketching angles. So in standard position, let me thicken this up a little bit like that. The first one asks us to draw as 5 pi over 6. So the first thing we should probably remember is to make an entire circle all the way around 360 degrees. I think we all established that. In terms of radians though, radians, that would be equal to 2 pi. So 360 degrees is 2 pi radians. So with that said, we're going to draw this out. So I'm going to start with my initial side, is right here. So 5 pi over 6, the way I always try to look at these as breaking them down into either 1 pi or 2 pi chunks. So 5 pi over 6 is just shy of 6 pi over 6, which would be 1 pi. 1 pi would be halfway around the circle. So 6 pi over 6 would get us all the way back around to the other side of the x-axis. But we don't. We're just shy of that by 1/6 of that. So that angle would be something like that, maybe. Okay, and then there, we just draw that in, and there's our 5 pi over 6. Simple as that. Let's do another one though. 3, it has a negative out front. I'm going to skip 5 pi over 4 for now and get to a negative example. So the negative 5 pi over 3, that again, we start our initial side to the positive x-axis, but this time we're going to go around backwards. We're going to go 3 pi over 3 is halfway around. 6 pi would get us all the way around, but we're only 5 pi over 3, so we're going to stop short by 1/3 like that. So negative 5 pi over 3, just like that. Let's do 5 as well. We'll get to 2 and 4 here in a minute, but 1, 3, and 5 I like because they all have very different aspects that we can learn from. So again, start with that initial side. Now 67 pi over 18, that is a big number. What I'm going to say about that is we can get our calculator out here, and I got 2 of them going. 67 pi's. Well, remember, every 2 pi is a full rotation. So if we did that, that's 36 pi. So if we went all the way around, that's 36. We still have some left over. If we went 2 times around the circle, 36 times 2 is 72. So we know that we're somewhere between 1 or 1.5 and 2 full revolutions. So when we do that, first of all, we're positive. We start at the initial, so there's 18, 36, 54, we're just doing increments of 18, so if you know your multiples, it's easier. There's 54, so 67, let's do that, 67 minus 18, so here's halfway around. There's a 1 full circle, 1.5 times around, and we are left with 13/18, so to speak. So that's kind of 13/18, that's pretty close to like a 2/3, 3/4 mark. So what I'm going to say is I'm going to go all the way down and around to I don't know, somewhere down here, and that'll finish off that 67 pi over 18. So, whoop, there we go. That's your representation. It just means that you've gone around the circle more than once. It gets a little messy. Real quick, let's do 5 pi over 4. And again, initial side. There's 1, 2, 3, 4 pi over 4. And then there's 5 pi over 4. So again, you're always looking to find whole pi or 2 pi increments. And when you look at pi over 4s, those are the nice, like, it's equivalent to like a 45-degree angle. So that's why I tried to draw it as best I could like that. 5 pi over 4. Last one in this video is negative 13 pi over 6. So again, standard position, we start to the right on our initial side, and going backwards, so clockwise, if I look at 13/6, I know that I'm, here's 6 is halfway around, 12 pi over 6 is 2 pi, we're 1 more sixth past that. And that's your negative 13 pi over 6. I think, yeah, we'll break this into a second video for the rest of the notes here, but that is what we're looking for in the first part, sketching the angles in standard position. Starting with the positive x-axis, a positive angle would go counterclockwise, negative counterclockwise, or clockwise.